Forces.
In our basic schools, force was defined as the push or pull on an object. Rather, a force is anything that causes a change in a body's state of rest or uniform motion. Newton is the SI unit for force. But Newton is defined as the force required to cause a body of 1 kg mass to move with an acceleration of 1 meter per second.
What are the main types of forces?
Contact forces are forces experienced by bodies when touching each other. Examples are the frictional force, the cohesive force, upthrust, and the normal reaction. The second type of force is what is termed as the field forces, and they are forces experienced by bodies within a region or an area. And these are examples of contact and field forces.
Frictional force.
The force that opposes movement between surfaces in contact is known as the frictional force.
Types of frictional force.
There are two types of frictional forces: the static or limiting frictional force and the dynamic or kinetic frictional force, which is sometimes known as the sliding force. Static friction is the frictional force that occurs between stationary objects, whilst dynamic friction occurs between moving objects. Let's assume the first object on a table. There is a force that opposes the weight of the object, and that force is termed as the normal reaction. If the second object is pulled to the right, there is going to be an opposing force, and that force is the frictional force. So the frictional force occurs in the opposite direction to the applied force. As the tire of a car moves on the road, there is the presence of friction. To any direction the tire moves, frictional force opposes the tire's movement. And thanks to friction, one is even able to drive on the wet road. Now, the markings on a car tire is not just for beautification, but to aid in friction. Now, imagine driving on a wet road with no friction between your car tire and then the road.
Look at the loss of friction.
Frictional force depends on how rough or smooth the surfaces in contact are.
2.
Frictional force is directly proportional to the normal reaction of a surface on a body. We will delve into this second law later.
3.
It doesn't depend on the area of the surfaces in contact.
Advantages and disadvantages.
The basic advantage is that it aids in movement. Now, the disadvantage is that it causes wear and tear. It reduces the efficiency of machines. It produces heat. It wastes energy. Friction between surfaces can produce noise. There is the increased cost of maintenance.
The second law of friction.
Frictional force is directly proportional to the normal reaction of a surface on a body. So, the force is directly proportional to the normal reaction. Let's just make it this way so that you remember that that is normal reaction. So force is directly proportional to the normal reaction of a surface on a body. Now, this sign of proportionality implies that force is almost equal to the normal reaction. So there is a negligible coefficient. If that is the case, for us to do away with this sign of proportionality, we can introduce an equal to and then a constant of proportionality. In this case, let's use mu, where F is the force, mu, this is the constant of proportionality, and then our R is the normal reaction. We have force being equal to mu R. Now, we can find the constant of proportionality by dividing both sides by normal reaction. So this cancelling this will give us the constant of proportionality to be equal to force over the normal reaction. So coefficient of friction is the ratio of the frictional force to the normal reaction. Realize that force is measured in Newton. Now, this normal reaction is also a force that opposes this. That is also measured in Newton. So they tend to cancel out. What it means is that mu has no SI unit. If you should see K as a subscript, that is kinetic friction. If you should see S, that is static friction. And note that the static friction is always greater than the kinetic friction. So let's solve questions under this to better understand.
It's question time.
Let's get the important information out of the question. So our data. What is the coefficient of friction? So the coefficient of friction is not given. Between a wood of mass, now we have the mass of a wood to be 1.6 kg and the horizontal surface with the limiting frictional force. Now limiting frictional force is the same as the static frictional force, and that is 8 newtons. We are finding the mu. We know that mu is equal to force over the normal reaction. But in this case, our force is given, but normal reaction is not given. This is the wood, then this is our horizontal surface. We've been given the mass of this wood to be 1.6 kg, the limiting frictional force to be 8 newtons. But with the mass, we can find the weight. We know that weight, or the normal reaction, is equal to mass times acceleration due to gravity. So in this case, we've been given our mass to be 1.6 times our acceleration. Acceleration due to gravity, let's take that to be 10 meters per second. Now, as we multiply, we are getting it to be 16 newtons. So mu is equal to, the force given is 8 newtons divided by 16. So these are in newtons. This will cancel out. Found our coefficient of friction to be 0.5. With question 2. Now we know that our coefficient of static friction is given as force of static friction over the normal reaction. But in this case, normal reaction is not given. So let's find normal reaction, and that is the mass times acceleration due to gravity. Mass is given as 0.5. So 0.5 times acceleration due to gravity is given as 10. And this will give us 5 newtons. So in this case, we have a force of 2.5 newtons divided by 5 newtons. And that is given as 0.5.